Hello friends, very good morning. A hearty welcome to my YouTube channel. And in today's video, we are going to work out a very nice problem or a very important problem on the projection of a square pyramid which is going to be suspended from one of its corners of the base, something like this. So if you hold it like this, or if it is fully suspended from one of the corners of the base, how does it look? So friends, what I do, I have this square pyramid of side 30 mm and height 60 millimeter, and I just keep it on HP such that it has to have one of its corners to your right side, or in other words, this corner should come to either to the left or to the right. So friends, I write down the initial front view and top view of the pyramid when all the four edges of the base are equally inclined to VP. Obtain the top and front views. Friends, now I have constructed a square of the given side 40 millimeter with one of the base edges at 45 degrees to VP, are all the four edges equally inclined to VP, and obtain the top view. In the top view, these lines OA, OB, OC and OD represents the four slant edges of the pyramid. And for the given height, I have projected all these points upwards and marked them as A dash, C dash, this is B dash, D dash, and this is O dash. O dash is the front view of the vertex, and friends, here now it has to be freely suspended. That means to say that object will be in space, so it will not be touching the ground now. So we have to suspend this, say, by a small thread, so that it will be something like this in front of you. So what do we do, friends? For all the pyramids and the cones, we have to locate the center of gravity, that is CG of the solid. Remember, for the pyramids and for the cones, the CG, which is represented by G, is at a height of 1/4 the total height from the base. That is, if the height is 60 from the bottom face, it will be at a distance of h by 4, that is 60 by 4, that is nothing but 15. So similarly, if it is a case of a cone, you are going to have the same value, 15 by 4. So what I do, I locate the center of gravity in the front view, mark it as G, and then join that G to C dash. So this G and C dash represents the line joining one of the corners of the base of the solid with the center of gravity, which is at a height of 15 millimeter in this problem. So this is the height we have got. Friends, the next step is very important. We have to redraw this figure such that this line C dash G, C dash G becomes vertical or perpendicular to XY. With this construction, we have to redraw this figure. So how to do that, friends? Say this C dash G is making an angle of alpha with O dash C dash. So at this point C dash, I have written a line O dash C dash which is making alpha. So you have to just use this data, make that angle. Then friends, once you have this line drawn, you know what is the acute angle here. You can complete this figure. So here, none of the points on the periphery should touch the XY because it is freely suspended by something like, by a thread, say. It is suspended like that. It is held like this. Friends, here afterwards, whatever the procedure we follow for other solids holds good. So once again, I would like to remind you, these two figures are exactly identical, and if you have got to write the top view for this, Friends, if you write the vertical lines from all these and horizontal lines from here, you are going to get the base of the solid which is completely visible to the observers in the top view. That is how I have completed ABCD. So this is this base. Now friends, vertex is here, vertical line from O dash, horizontal from here. They meet at this point, and you know OC is visible and OB, OD are also visible. Hence, I am going to join all these by straight line. These are all visible, so to be joined by straight line. And friends, even this is visible. So we have got this. This OA is not visible, so I have to show that this OA is not visible, hence to be shown by dotted line in this portion, because that is the body is an opaque body. Friends, we have got the top view, we have got the front view when it is freely suspended from one of the corners, that is C. Now friends, in the question it is said that the axis appears normal to VP. So we had this pyramid like this, which was kept like this, and now friends, the axis is now here coinciding with this line. Now that is parallel to VP. I'll write down here axis parallel to VP, but it should appear like normal to VP. So I have to redraw this figure such that that axis O1 becomes vertical as I have shown. So we are going to redraw that figure and obtain the corresponding front view. Friends, we are going to get points one by one. Let me start with A. Draw a vertical line from a horizontal line from here. This point is going to be the point A dash. Similarly, B, vertical line from B, horizontal line from B dash. This will be the point B dash. This becomes C dash. Finally, this is point D dash. And the vertex O of the solid is here. Draw a horizontal from the vertex O, a vertical line from here, and this will be obtained here. This point is O dash, the vertex, and this point is O1, the center of the base of the solid. Now friends, it has become like this. The object was like this before, and now it has become perpendicular like this. So friends, you will be able to see these two triangles, and this corner which is away, that is A, is not visible to us. So friends, we will complete the projection by joining these like this. So O to A, that is all the borders are visible. This should be visible. This is visible. These two triangles are visible. This is visible. And here only this is not visible. The point A is not visible in the front view, and hence the lines joining that A or A dash with the D and this are not visible. So friends, it is something like this. I would like to show again to you. So this tip is visible. So I have to join this till here. Point A is not visible, and hence all the corners connecting that A, such as AD and AB, are also not visible. Hence I represent them by dotted line or invisible line. Friends, you can observe here that the object is freely suspended from the corner C, that is seen as C dash here. This is the final front view of the solid, and this is the top view of the solid. We should be exactly like this. So I have shown all this, and this is the top view of the square pyramid. We have to darken all these lines. This is how it looks in the front view finally. Friends, this is how finally the object looks. And remember friends, whatever the principle I have told you, how to locate the center of gravity, that is CG of the solid. And this principle can be applied for any problems on any type of pyramid and also the cone. And remember that the center of gravity of all these pyramids and cones lies at a height of 1/4 the total height of a solid. If the height is 100, it will be at a distance of 25 mm, that is 100 by 4. If it is 120, it will be at a distance of 20. And for drawing or for solving problems when it is freely suspended from the corner, you should always take one of the corners of the solid coming to your right side in the initial position of the front view. And again, friends, remember whatever the concept I have told you in my previous videos, that is figure number 1 and figure number 2 in the front view, they are exactly identical. Similarly, figure number 3 and figure number 4 are going to be exactly identical. And if you remember this, friends, you can solve any number of problems when the cylinder, prism, pyramid, whatever it may be, freely suspended from a point on the base or a corner of the top face or the bottom face, whatever it may be. Friends, I hope the presentation was interesting, and please go through the complete video without fail and without skipping anything in between. If you like this video, do share this video with all your friends and have a wonderful Sunday. This is Dr. M.H. Annaya signing off.